hole collisions or massive explosions of supernovas don't stand a chance. Here's a quick experiment. Put a tiny bell into a plastic bottle and screw the cap on. Now shake the bottle and listen to the bell. Now take off the lid, put 2 burning matches inside, and quickly put the lid back on so they burn out. Once the air in the bottle cools, shake it again. Notice how the sound is quieter, or is not there at all. Nevertheless, there are different electromagnetic waves that travel through a vacuum without problems, and radio waves are one of them. Although our human ears cannot spot such signals, scientists found a way to convert them into sounds, and now we can hear the message Voyager 1 sent us. So, how did Voyager 1 manage to gather such faint signals and send this data to Earth? Well, the spacecraft was designed with 2 hypersensitive antennas designed to detect plasma variations in space and record them. But even using radio signals for communication that travel at the speed of light, more than 20 hours have to pass to cover such a distance. The sad truth is that soon we won't receive any signal from Voyager 1. According to scientists, it's currently running out of power, so the probe's crucial instrument may function for 3 or 4 more years. Voyager has already done more than we've ever expected, and it could still surprise us with more life-changing discoveries throughout the following years. Even though the latest probe's finding is kind of a big deal, NASA has previously discovered some other weird sounds that puzzled scientists. In 2007, researchers unexpectedly came across something bizarre stored in a few years old data. What they revealed were so-called FRBs, fast radio bursts. These are so quick that each burst only lasts about a millisecond. From this point, researchers have started searching for other possible FRBs, and they found tons of them. This is how these radio bursts sound. So far, it seems the more we find out about the universe, the more questions there arise. Could it be an attempt of an intelligent alien civilization reaching out to us? Or maybe this wasn't intended for our eyes and ears. Who knows? The majority of astrophysicists think these FRBs either come from black holes or massive neutron stars. Probably the smallest yet some of the heaviest and densest stars out there. Other professors had a more thrilling idea of what was actually happening. Their theory is that these were powerful, misaimed alien radio signals that were intended to charge their light-driven cosmic ships at huge distances. What both sides do agree on is that these FRBs must come from an unimaginably distant source somewhere billions and billions of light years away from our galaxy. And while our technologies are limited to look that far, we seem to have harnessed our own solar system quite well compared to interstellar space. And NASA occasionally notices spooky sounds way closer within our planetary system. Let's take a look at Jupiter's moon, Ganymede. Here's the disturbing sound it makes. The reality is that these sounds are as a result of chorus waves, coherent electromagnetic waves. Now, these waves frequently cause auroras or polar light, and the Earth is not the only place you can see those. This breathtaking phenomenon happens on Saturn, Jupiter, and Ganymede as well. So, What you've just listened to could be basically a converted sound of polar lights on Ganymede. What about Mars, though? We've been studying it for quite a bit already, and NASA's Perseverance rover has just come across something fascinating. The first actual sound of the rover driving over Mars has been recorded. But what's interesting about it? Well, along with the noise of the metal wheels rolling on a rocky planet's surface, Perseverance has captured an unidentified, high-pitched scratching sound. Here's the actual recording sent by Perseverance. Nobody knows what the cause of this scratching noise is, and while NASA's scientists try to get a clue, the mystery remains unsolved and leaves room for imagination. Scientific and technological progress do not stand still. In 2030, a prospective interstellar probe mission may take place. Scientists say this could be just as revolutionary as the very first attempt to land on the moon. Just imagine the largest rocket flying the highest possible speed to get 10 times farther than Voyager 1 got at the bare minimum. An expected lifespan for such a spacecraft is 50 plus years, but given Voyager's success and today's advanced technologies, everybody hopes to see this number rise. This would be humanity's first significant step into the realm of stars. The mission's primary objective is to capture our entire solar system from a huge distance and continue with the exploration of interstellar space. Once done, we will finally get closer to defining our place in the universe and unraveling the mystery of deep space. The planet Earth isn't going to be habitable forever. If the human race is going to survive, one day we'll have to pack up our things and move to another planet. It sounds easy until you realize the vastness of space and even how big our solar system is. No matter where we're going in space, we need to travel fast, and not just at the speed of light either. We're talking about ludicrous speed. But some researchers have designed an impossible engine that violates the laws of physics. And another group of scientists are now saying a warp drive is possible. Is NASA really working on this technology? And what does the future hold for space travel? Consider this for a moment. Our closest neighbor, Alpha Centauri, is 4.367 light-years away. So even if we traveled in a ship at 100% light speed, it would still take you 4.367 years to get there. We could use rockets to get ourselves around in space, but the big problem with them is the amount of fuel we would need to carry to get anywhere. But even rockets have their limits, including how fast they can push a spacecraft. We're going to need something that can generate some serious thrust and be able to do so without carrying a large amount of fuel, because in space there are no gas stations. But there is an engine out there that reportedly can push a spacecraft around without the need for fuel. And this engine produces no exhaust either. You just plug it in, fire it up, and go. It's called the EM drive, or impossible engine, because it claims it can do the impossible. So how does this EM drive work? At first glance, it actually does look a bit like a rocket engine from the side. However, there are no openings in the device, and it works by bouncing around microwaves inside a closed chamber. That bouncing around of microwaves in the chamber is supposed to create a push, so to speak. This is a big deal, because all forms of rocketry require some conservation of momentum. In order to put a spacecraft in motion, you've got to push off something. For example, if you jump, your feet push off the ground. An airplane pushes off the air, and rockets use exhaust gas to push them and whatever they're carrying forward. But the EM drive doesn't push off anything. Basically, it's a container with microwaves bouncing around inside it, and it can supposedly move itself. Now you understand why this is called an impossible engine. The explanations for how this thing works goes past our current understanding of physics. Nobody really knows how it's supposed to work. It could turn out that our understanding of physics is broken, or perhaps the testing of this device will give us some brand new physics. The EM drive concept came to life in 2001, and there have been some research groups that claim they've measured a net force coming from their devices. However, what they're measuring is an incredibly small effect. So small, it couldn't move a piece of paper. So what we have after nearly 20 years is a bunch of experiments that haven't delivered something worth talking about, or any explanation of how they work. Some experts say that this drive will never work, and all projects will likely be a waste of time and money. It's possible that our understanding of physics or new physics not yet discovered could make this thing work. But there are other space engines out there that people said would never work, and they sprang to life. We're talking about the ion drive, something that was only thought possible in science fiction when this was first imagined. And when people first heard about a real ion drive, they also thought it would never produce enough power to move a small spacecraft. But the ion drive really does work, and in 2016, NASA awarded the California-based company Aerojet Rocketdyne $67 million to design, build, and test an advanced and super efficient solar electric propulsion system, or SEP for short. They also call this drive a Hall effect thruster that uses propellant accelerated by an electric field. The ion drive works first by converting solar power to electricity. That electricity is used to accelerate ions out of a nozzle, which in turn generates thrust. It turns out that engineers have been developing SEP technology for more than half a century, and there are ion thrusters on multiple spacecraft, including NASA's Dawn probe, which is now orbiting the dwarf planet Ceres. There are plans to use the SEP drive for missions to Mars, but the issue with the ion drive is that it transfers a very small amount of momentum to the spacecraft. But while ion drives are slow, they're among the most fuel-efficient of all spacecraft propulsion methods. Right now, NASA is using a high-power electric propulsion system for the Lunar Gateway, an outpost that will orbit the Moon. In April 2021, NASA fired up the ion thruster system, which is about 30% more powerful than previous designs. But NASA started to look at another means of getting spacecraft quickly to their destination: nuclear pulse propulsion. Around the same time that nuclear jet engines were being developed for bombers, there's been some interest in using nuclear reactors to power spacecraft. One thing is that they can survive the cold, dark regions of space without requiring any sunlight, and they're also reliable. The Zeus reactor is designed to last 10 to 12 years, and it could propel spacecraft to other planets in less time. But there are some problems with this propulsion system too. Only fuel like highly enriched uranium can withstand a nuclear reactor's extremely high temperatures, and that doesn't make them safe to use. But there is another blow to this type of propulsion system, because the US recently prohibited the use of highly enriched uranium to propel objects in space if another safe means was possible. Right now, Russia is planning to launch a nuclear-powered spacecraft that will travel from the Moon, Venus, and then to Jupiter. Roscosmos said that its space tug will launch in 2030. The energy module that will power this spacecraft is called Zeus, basically a mobile nuclear power plant, and is designed to produce enough power to push heavy cargo through space. Right now, it would take more than 3 years to make a round-trip visit to Mars, but NASA figures that a nuclear-powered spacecraft can cut a year off that time. Now NASA wants to integrate a 10-kilowatt nuclear power plant with a lunar lander and put it on the Moon as early as 2027. The USA has never put a nuclear reactor into space, but Russia has put more than 30 reactors in space so far, and Zeus will use a 500-kilowatt nuclear reactor to jump from planet to planet. Advances in nuclear technology, such as nuclear fusion, may well change everything, but some say we're still far away, and propellant-powered rockets are the best we have at the moment. Propulsion of any spacecraft usually requires some sort of propellant, but there are other methods that use only the sun itself. Solar sails have been in development for many years now, but now that technology is advancing, spacecraft powered by the sun are fast becoming a reality. In 2019, SpaceX launched the LightSail 2 using the SpaceX Falcon Heavy. The $7 million LightSail 2 is 344 square feet in size and has sails made of tear-resistant mylar. When radiation pressure from the sun hits this material, it creates pressure which moves the spacecraft. So how fast can it go? That depends on how much sunlight is hitting the sails, and if the craft is far away from a star, it's going to move much slower. But what about warp drive technology? Just because you've heard that warp drive would be impossible to design and create, doesn't mean it won't happen. In fact, scientists have just recently announced that a physical warp drive is now possible. Yes, seriously. In the new paper, researchers say that they've nailed down a physical model for a warp drive. Many have said the technology is impossible because it would require a huge amount of exotic negative forces. We all know the term warp drive comes from the famous science fiction series Star Trek. The Federation's faster-than-light-speed warp drive works by colliding matter and antimatter, which produces explosive power. But what about warp drives in reality? Our current understanding of the warp drive comes from the now iconic theoretical physicist named Miguel Alcubierre. This drive conforms to Einstein's theory of general relativity to achieve superluminal travel by a local expansion of space-time behind the spaceship and an opposite contraction in front of it. But the Alcubierre drive would need a ton of energy, probably more than what's available in the entire universe, in order to contract and twist space-time in front of it and create a bubble. If you were an astronaut inside that spaceship with the bubble around it, you wouldn't feel any acceleration. NASA has actually been trying to build a physical warp drive for the last decade, but hasn't made much progress yet. But this brings us to the new study. Scientists at the Advanced Propulsion Laboratory at Applied Physics unveiled the world's first model for a physical warp drive. where the existing model uses negative energy or exotic matter that doesn't exist or is impossible to generate with our current understanding of physics. This new concept uses floating bubbles of space-time rather than floating ships in space-time. In fact, this new physical model uses almost none of the negative energy needed in the previous model and capitalizes on the idea that space-time bubbles can behave any way they want to. Alcubierre even endorsed this new model. However, this is just a concept for now, and the mass requirements needed are still enormous. But while a physical drive may not be a reality today, or even a century from now, with this exciting new model, warp speed travel is a lot closer than we previously thought. It's been long thought that there are objects out in space moving around between stars, and sometimes they can pass through our solar system, and not long ago, something from deep space made a surprise visit. Some say this visitor was a comet, or maybe an asteroid, but another astronomer strongly believes it's something completely different. Was it the splintered remains of an exoplanet? Or was this interstellar visitor some kind of alien spacecraft in disguise? And why do some believe this? On October the 19th, 2017, the very first known interstellar object to enter our solar system was detected by astronomers using the Pan-STARRS Observatory in Maui, Hawaii, a big telescope equipped with one of the world's largest digital cameras with almost 1.4 billion pixels. What they saw was a small point of light flashing through our solar system like a beacon from a lighthouse, not typical of an asteroid or a comet. In fact, it was something no one had ever seen before. Astronomers named it Oumuamua, which means a messenger from afar arriving first, and at the time, they believed it was some kind of elongated cigar-shaped object tumbling through space because of the way it changed brightness. It was estimated to be bigger than the Eiffel Tower, some 1,312 feet long and 130 feet thick. It wasn't discovered until it was on its way out of our solar system, 40 days after passing the closest point to the Sun on September the 9th, 2017. And it was moving incredibly fast, about 196,000 miles per hour. And the way it was whipping around the Sun told scientists that this object had to have come from somewhere beyond our solar system. The object flew past the Earth so fast that its speed couldn't be from gravity of the Sun alone. In fact, the Sun had nearly no influence on this unknown object as it hurtled through our solar system. The strange thing about Oumuamua is it's not an asteroid, and it doesn't look anything like your ordinary comet. However, it behaves like a comet. Comets are small, icy bodies that develop tails made of volatile materials seen vaporizing off the comet's body from the heat of the Sun. It just so happens that the second interstellar object discovered in our region of space in 2019, Comet 2I-Borisov, behaved and acted like a normal comet did, and this made Oumuamua look even stranger. Astronomers were unable to explain Oumuamua's movements through space by the force of gravity alone. Some researchers believed that Oumuamua was jetting out gas from the sunlit side that would push the object like a rocket. However, the problem with this is there was no detectable escaping gas, no tail like you would see from a typical comet. Not only that, the push seen from Oumuamua was stronger than what scientists would have expected to see from any other ordinary comet, and it was a continuous push. If cometary outgassing is ruled out, and then inferred excess force is real, then only one possibility remains, and we'll get to that in a moment. The way in which the object accelerated had many believing it was an alien spacecraft, perhaps some kind of extraterrestrial probe powered by some internal power source. The other strange thing is that no one had a clue to what solar system it came from, or how old the interstellar visitor is, because it was traveling so fast that no telescope could grab a decent enough image to give us an idea of what it really looked like, or what it was made out of. This greatly added to the mystery. Some researchers have come to exotic conclusions to what this first interstellar visitor could have been, and where it might have come from. A Harvard professor of astronomy by the name of Avi Loeb said that Oumuamua is indeed an alien spacecraft, which is powered by a light sail, the method of propelling a spacecraft using radiation pressure given off by the sun or huge mirrors. The only way to make sense of Oumuamua's strange acceleration without resorting to some sort of undetectable outgassing is to assume that the object was propelled by solar radiation by photons bouncing off its surface. And the only way the object could be propelled by solar radiation is if it were no thicker than a millimeter and have a very low density with a large surface area. This object could function as a sail powered by light rather than by wind. Such an object could be produced by nature, leaving the only other explanation that Oumuamua must have been designed, built, and launched by an extraterrestrial intelligence. He further explained that the non-gravitational acceleration is a sign of deliberate maneuvering, and Oumuamua has no comet tail showing any outgassing. There's no way of proving or disproving this theory, and a claim like this one from an experienced and well-respected astronomer is very unusual. But another theory has now surfaced that might explain what Oumuamua really is. It's now believed the object could be like a pancake, or a giant cookie-shaped piece of debris, a piece of shrapnel from an exoplanet like Pluto. In 2021, two Arizona State researchers published a pair of papers arguing that the object could be a hydrogen iceberg. These researchers think that some space object hit the planet where Oumuamua originated from, and the violent collision sent the chunk of planet careering towards our solar system around 400 to 500 million years ago. In the beginning of discovery, researchers thought it might be a long, thin, cigar-shaped object tumbling end over end, and something unknown appeared to be making Oumuamua move faster, as if something was pushing on it. But now, researchers think they understand this strange visitor, and it is neither an asteroid or a comet. No one is certain what Oumuamua is made of, so scientists calculated the different kinds of ice that would change from solid to gas at a rate that accounted for Oumuamua's rocket effect, and concluded that the object must be made of nitrogen ice, the same stuff you'd find on the surface of Pluto or Neptune's moon, Triton. And here's a big surprise. Our first interstellar visitor actually entered the solar system way back in 1995. As it got closer to our solar system, and therefore the Sun, the chunk of planet started losing layers of frozen nitrogen. By the time we discovered it, the object had already lost 95% of its mass, melting into the small chunk that was detected. So maybe after all, it isn't some type of alien technology, but the idea of a piece of an exoplanet flying through our solar system is still exciting, if not downright scary, depending on where it's headed. Right now, the object is leaving our solar system, and will leave our solar system and enter interstellar space in the late 2030s, never to return again. But there is something called Project Lyra, which develops concepts for reaching interstellar objects like Oumuamua. The goal of the project is to see if it's possible to send tiny spacecraft to intercept and study interstellar objects. But the challenge to catch Oumuamua is formidable. This is because it's moving at 5.5 astronomical units per year. That's 465 million miles. And it will be beyond Saturn's orbit very soon. This is much faster than anything we've ever sent into space, and the challenge of sending a spacecraft to catch Oumuamua pushes the current envelope of space exploration to the limit. Despite this, a mission is possible, and a tiny light sail spacecraft could be launched in 2030 to 2033 and reach Oumuamua by 2047 and 2049. We've already built the Light Sail 2 spacecraft, which has a sail the size of a boxing ring made from a sheet of mylar. This same kind of solar technology could be used to send tiny probes quickly through space just by bouncing a high-powered laser off their tiny sails, and perhaps one that could catch Oumuamua and finally tell us exactly what it is. The observable universe spreads across an expanse so big that it warps the imagination. And although there is a cosmic boundary we can see, many astronomers believe there could be much more out there in the darkness, billions and billions of light years away. And it seems there is something strange and mysterious out there with an immense gravity pulling on everything. Space is expanding at an accelerated rate, and giant space structures farther than we can see could be out there tearing space apart. And we may have found one of these in our own universe. The universe is larger than we can comprehend. Currently, we know there are at least 100 to 200 billion galaxies out there that we can now see. But it's a good chance there could be 2 trillion galaxies or more in our observable sphere alone. We just can't see them. We all know that the observable universe is estimated to be approximately 13.7 billion years old. This is defined by the speed that light travels, and astronomers came up with the age of the universe by measuring light that has reached us from the oldest and most distant stars. We define observable space by the light that has reached the Earth and can be seen. Cosmologists estimate the oldest photons we can currently see have traveled a distance of 45 to 47 billion light years since the hotly debated Big Bang theory. This means that our sphere of observable universe is around 93 billion light years across. To give you an idea how big that really is, 1 light year, which is the unit of astronomical distance that light travels in 1 year, is 9.46 trillion kilometers. With that in mind, the big question is, how can the universe be 93 billion light years across if it's only 13.7 billion years old? This means that the universe could be older, much more than 14 billion years. We know that anything further away from the light that we see from the beginning of the universe, or the cosmic Big Bang, hasn't had enough time to reach us. Thus, we can't see what's out there. It's pitch black. But does this mean the edge that we can see is all there is? The truth is, there could be a lot more out there. Ever since the Big Bang, the cosmos has been growing at an increasing rate. It was Edwin Hubble that discovered that the universe is expanding and that all galaxies are moving away from the Milky Way. Not only are these galaxies moving away from us, but the farther away they are, the faster they're flying away from us. In fact, Hubble found that for each additional megaparsec of distance, galaxies receded 500 kilometers per second faster. This became known as the Hubble constant, and the area of our observable universe is called the Hubble volume. One thing we need to understand is that the word observable in this sense doesn't refer to the capability of our current modern technology to detect light or other information from an object, or even if there is anything to be detected. Observable here in this case refers to the physical limit of the speed of light itself, which is its maximum speed. When talking about the distance of anything in space, we're also talking about time. Looking up into the night sky is a little bit like time traveling. All those glittering stars in the night are only snapshots of what those stars looked like in the past. Just think about it. Some stars and other objects in the cosmos are so far away that their light can take thousands to millions of years to reach planet Earth. And if there is something beyond the edge of the observable universe that we can't currently see, it means that these objects are so far away from us that their light still hasn't reached us. The cosmic horizon is the measure of the distance from which we can retrieve information. But is there something out there past what we can see? It's really tough to answer this. However, to get some idea if there is something out there, we need to take into consideration the curvature of the observable universe. The thing is that astronomers aren't really sure if the universe is infinitely big or just vastly huge. In order to measure the universe, astronomers look at its geometric curve on large scales, which tells us about its overall shape. If the universe is perfectly geometrically flat, then it can be infinite. But if it's curved like Earth's surface or is like a bubble, then it has finite volume. Current observations and measurements of the curvature of the universe show that it's almost perfectly flat, like a sheet of paper. That would indicate that it must go on forever. We know with some certainty that there is more universe out there beyond the boundary that we can see. Astronomers believe that space could be infinite, with more of what we already see. And it's probably distributed the same way as it is here in the observable part. Now here is one of the mind-blowing things to think about if the universe is infinite. If this were to be true, then you wouldn't just find stars, different planets and galaxies. You would eventually find every possible thing. Think about that for just a moment. You would find everything. If you went far enough, you would find a solar system identical to ours in every way, including a planet Earth and your twin, except that a copy of you might have eaten cereal this morning instead of a version of you that skipped breakfast altogether. It's a fact that some cosmologists think if you go far enough, you would eventually find another Hubble volume that is identical to ours, with a version of yourself mirroring your every action. Now, while that might sound impossible to what our minds can grasp and understand, there is something else very strange and unexpected that was discovered by astronomers in 2008. They found that galactic clusters were all streaming in the same direction at over 3,218,688 kilometers per hour. It's a phenomenon called dark flow. This movement of galaxies defies all predictions about the distribution of mass throughout the universe after the Big Bang. So what is the mysterious gravitational pull on all these galaxies? One possible cause could be massive structures that are outside of the Hubble volume that are exerting a massive gravitational influence. In simpler terms, massive objects with a huge gravitational force pulling everything towards them. If true, this would mean that the structure of the infinite universe beyond our view is not uniform. No one knows what these structures could be. It's possible they're aggregations of matter and energy on scales we can barely fathom, or they could be gravitational forces of other universes. Speaking of massive structures, there is one in our universe that's so big that it shouldn't even exist. In fact, it's the biggest structure in the observable universe. It's called the Hercules Corona Borealis Great Wall, and it measures 10 billion light-years across. It's so big that it makes up 11% of the observable universe. To put this further into perspective, if you were traveling at the speed of light, it would take you 10 billion years to get from one end to the other. So why shouldn't it exist? The problem is that astronomers have no idea how this Great Wall formed only a few billion years after the Big Bang, and could have grown so big in such a short time. This means there could be giant structures like these out there pulling on everything, including space. One day it could very well rip apart the fabric of space-time itself. And speaking of gravitational forces from other universes, some astronomers believe that the post-Big Bang expansion of the universe created bubbles that formed in the structure of space, and each of these bubbles is an area that stopped stretching along with the rest of space and formed its own universe with its own physical laws. In this scenario, not only is space infinite, but each bubble is also infinite, because it can store an infinite number of infinities inside a single infinity. To make that seem a little more clear, even if you could breach the boundary of our bubble, the space in between bubbles is still expanding. So in the reality of space-time, you could never get to the next bubble, no matter how fast you traveled. But will we one day have the technology to see what is beyond the edge of the universe we can now see? The sad reality is that light from any object outside the Hubble volume will never reach us, because the space between us and it's expanding too quickly. For example, we may never see what a galaxy looked like 10 billion years after the Big Bang. This doesn't have anything to do with our limited technology, but instead the physical limits of the speed of light itself. This means that any light emitted by objects at a distance of 19 billion parsecs will never reach the Earth. As time goes on, more and more points in space will have time for their light to reach us, which means that the observable universe is still increasing in size, and that also means that the age of the universe will increase. That said, you might think that one day, if humanity is around long enough, the entire universe would become observable to us. But since space in the universe is continually expanding, the distance between us and everything else becomes farther and farther each second. However, the James Webb Space Telescope will be able to look farther into space, will look backward in time, and just may give us more answers to what else exists out there. In a sense, it's a time machine, and we'll be able to see further into the past. If humanity wants to explore the universe, we'll have to learn how to colonize and terraform other worlds. But what exactly would it take to terraform a planet? And do we have the technology to make a planet like Mars comfortable for us? Discover what stands in our way of terraforming, which places in our solar system are the best for human colonies to be built, and find out how we just created oxygen for the first time on another planet. Planet Earth is the only place where humans can exist, for now. It's a scary thought that if our planet suddenly started to become uninhabitable, we'd have no place to go. Mars is one planet in our solar system that could be colonized. NASA wants to put humans there sometime in the 2030s. But when we send humans to Mars, they'll need a way to return to Earth safely. And those astronauts will also need oxygen to breathe. Mars is a cold and desolate world with a thin atmosphere that's made up of 96% carbon dioxide. NASA already has several rovers running around on the Martian surface checking it out, looking for signs of ancient life and seeing how habitable the planet might be. The Perseverance rover recently landed there, and it brought with it a very important experiment called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It's a small toaster-sized box that has three main components. On April 20th, 2021, MOXIE became the first instrument to create oxygen on another planet by separating oxygen atoms from carbon dioxide molecules while using high levels of heat for the conversion. During the first run of MOXIE, it produced about 5 grams of oxygen. That's about 10 minutes worth of breathable oxygen for an astronaut. But this small car battery-sized unit can only generate 10 grams an hour. But now that MOXIE has proven it can produce oxygen, NASA plans to build a much larger unit, about 100 times larger. Another big achievement of MOXIE is that it's the first kind of technology that just used elements of another world's environment and turned it into a usable resource. NASA calls it in situ resource utilization. Oxygen is also needed for rockets, and to get off Mars, a ship or rocket would need about 33 to 55 tons of fuel. That's where liquid oxygen comes in. Mars-made liquid oxygen could supply more than 3/4 of the fuel needed to explore the red planet, and could also fuel other missions to nearby planets and moons. And if you mix hydrogen and oxygen together, you either produce water or hydrogen peroxide. And water is another important resource that we're going to need. 3 billion years ago, an ocean covered 1/3 of the Martian surface, but now 99% of Mars' water is ice. It should be possible to melt this ice and filter it so that it can be used. When it comes to colonizing the planet Mars, we could build big domes and pressurize those with a breathable atmosphere using a MOXIE system. But building domes and living inside them is no easy task, and we need to be sure we're up for that challenge. Take, for instance, the Biosphere project, which was a compound built in Arizona to see if we humans are able to build and live in self-sustaining colonies in outer space. We have a more in-depth video on the Biosphere project you can check out. Thanks to this project, we now probably understand exactly what we need to build these domes out of, and how we might be able to survive inside of them. Technology has come a long way since then, and Elon Musk says that we would live in big domes made of glass at first, and then we'd eventually terraform the planet over time. Colonizing Mars definitely seems possible, but is it really possible to terraform the planet? For those who don't know, terraforming is the process of taking a barren or desolate planet like Mars and turning it into an Earth-like or somewhat habitable environment. It sounds good in science fiction stories, but Mars has big problems that our current technology cannot overcome. Not as of yet. Mars has a very low atmospheric pressure, currently less than 1% of the Earth. That pressure would have to be increased a lot to sustain an atmosphere. Elon Musk joked about an idea to nuke the polar ice caps on Mars. And minerals and soil could also provide a source of CO2. But even if we used nuclear weapons and processed all those sources, we would only increase atmospheric pressure to about 7% of the Earth, which is 1013.25 millibars, or about 14.7 pounds per square inch. That means that any liquid water on the surface of Mars would freeze or evaporate quickly. And using nuclear weapons might only put the planet into a nuclear winter. It's still possible that there is enough carbon-bearing materials buried deep in the Martian crust that might hold enough CO2 to reach the pressure needed, but no one knows this for certain yet. But it's not the only problem. Mars is missing a magnetosphere, which means it will be difficult to maintain an atmosphere and ozone layer protecting the planet from solar radiation. And because the planet lacks any plate tectonics, it makes it incredibly difficult to introduce and isolate the proper amount of greenhouse gases life needs to survive. Mars also has lower gravity. Now, you might think it wouldn't be a problem, but lower gravity poses high health risks like bone demineralization, muscle atrophy, and weaker immune systems, as seen in some of our astronauts at the International Space Station. Mars is a cold and desolate place, but why fly to another planet if we want to try terraforming a cold and frozen wasteland? It seems the USSR wanted to do something similar, where palm trees could grow in Siberia, and the cold sea shores would turn into sunny, sandy beaches full of tourists. In the 1960s, there was a proposed plan by a Russian engineer named Petr Borisov, who wanted to build a dam across the Bering Strait. The reason is that 80 million years ago, at the boundary between the Mesozoic and Cenozoic, the Earth was in one of its most favorable states. The latitudes of Siberia and Alaska were in the subtropical zone, and the Arctic islands and Antarctica were covered with forest. All that's needed to return the area to this state is to restore the Cenozoic water exchange between the polar basin and the equatorial seas. But building a dam like this would take an incredible amount of resources. The width of the strait in the narrowest part is 45 miles, and the maximum depth is 193 feet. It was proposed to build the dam from large reinforced concrete blocks delivered by the sea. The width of the pontoon blocks would have to be 131 feet by 820 feet long, with a height of 65 to 196 feet. The dam itself would have been 55 miles long. The result would have been an increased flow of heat to the Arctic, and gradually the Arctic Ocean would lose all its ice, and temperatures in the northern part of Eurasia will increase. Of course, this project never took place, and we can already see the warming of Siberia now. But what about something not on Earth, but right next door? It turns out that the Moon has long been considered a potential site for terraforming. One of the reasons it would be easier is because it's a lot closer to us than Mars, and transporting people and equipment would take a lot less time. Because it's close, any resources or products made on the Moon could be shuttled to Earth in much less time. And a tourist industry would definitely pop up, with people wanting to go to the Moon for their vacation. But the Moon has a really thin atmosphere, if any at all, and the volatile elements needed for life don't exist there or are in short supply. In an impossible task of creating an atmosphere, you'd need to bombard the surface of the Moon with comets that contain water ice that would release gases and water vapor. The presence of water ice in the lunar soil and large patches around the southern polar region could be used to create surface water once a greenhouse effect was triggered. Getting the moon to start to rotate again by crashing asteroids into it, since it's tidally locked to Earth, would also have to be achieved. All this sounds really impossible, but there's another idea to terraform a place on the moon called Shackleton Crater, where scientists have already found evidence of water ice. By using solar mirrors and building a dome over the 13-mile-long and 2.6-mile-deep crater, a microclimate could be created where plants could be grown and a breathable atmosphere created. Once again, we lack the technology to pull any of this off, but it still might be possible to see some type of subsurface installation built on the moon for future human explorers. Another surprising place that we might be able to terraform one day is Venus. Venus is considered Earth's twin because they're almost the same size in mass and are rocky terrestrial planets. Venus also orbits the Sun in the habitable zone, and it's close, making it easier to transport explorers and supplies. The gravity of Venus is about 90% of what we experience here on Earth. Venus doesn't have a problem with a thin atmosphere. In fact, it's the opposite, and is 90 times thicker than the Earth's. The surface of the planet is also hot enough to melt lead, and the air is a toxic combination of carbon dioxide and sulfuric acid. It definitely doesn't sound like a place you want to visit anytime soon. But despite this being a hellish world, scientists think it's a better candidate for terraforming than Mars. Reducing the heat in the atmosphere would be the first thing on the list, but this would require a huge amount of energy and resources, using advanced materials which likely don't exist yet. A huge orbital shade large enough to cool the atmosphere enough could be built. However, we're talking about a structure that would need to be 4 times as big as Venus itself, and it would have to be assembled in space, which would require a massive fleet of robot assemblers. Increasing the speed of Venus's rotation would also have to be done, and this would require a huge amount of energy, such as directing several asteroids into the planet using large fleets of spaceships equipped with advanced drive systems. But thousands of impactors would be needed. But there is even another world out there that scientists say could be terraformed. The Saturn moon Titan is appealing as a place to terraform because of its vast reservoir of resources. Its hydrocarbon reserves, such as petroleum, are several hundred times greater than all known reserves on Earth. It's covered in a wide variety of organic compounds, mostly methane and ammonia, and it has a lot of water. Its atmosphere is primarily nitrogen, resembling that of early Earth. Together, all this stuff has the main ingredients for a perfect place to terraform when we have the technology. To change the atmosphere, one idea is to position huge mirrors in orbit to direct sunlight onto the moon's icy surface, which is ice and contains many greenhouse gases. This could warm the place up considerably and at the same time release water vapor, which would in turn oxygenate the atmosphere. Titan also orbits most of the time with Saturn's magnetosphere, which would protect it from the solar wind. Despite all the major technological challenges we face, most of humanity believes that we need to find a second home in our solar system. The big question is, which one should it be, and when will it happen? Let us know what you think, and make sure to stay tuned here for more amazing videos of our planet and the universe we live in. The Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime.
Let's liftoff of the Delta II rocket with
Launched in 2009 as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96 megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron, and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but 2 stars. If you were standing on the surface of one of these planets, you'd be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, 2 scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K2-18b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet, Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey Satellite, or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit, or -73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth and a surface temperature conducive to life. Given that about 20% of stars are Sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets, in fact the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is KOI 5AB. Astronomers first flagged KOI 5AB as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago, firstly due to the enormous amount of data that Kepler generated, and secondly because astronomers noticed that the main KOI 5A star had another companion star, making analysis very difficult for them. Indeed, the KOI 5 system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the KOI 5 system actually harbors 3 stars, and it still wasn't clear if the planet KOI 5AB actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of KOI 5AB. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of KOI 5AB is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They're more massive than Earth, yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets are super-dense, larger-than-Earth worlds in close, hot orbits around their parent stars. Some of them, known as Chthonian planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets, planets of various size found in strange locations, and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October 2018 as it ran out of fuel. The telescope was deactivated with a good night command sent from mission control the next month. Coincidentally, Kepler's retirement fell on the 338th anniversary of Johann Kepler's death, after whom it's named. Although not operational anymore, these incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope is already slated to go up into space in 2021. The James Webb Telescope will take a much closer look at some of these Kepler objects of interest and hopefully will bring us closer to answering the question, are we alone in the universe? Before modern telescopes, humans could only imagine what the surface of the sun and the planets looked like. Now, advanced technology has made it possible to get in close and take images of the sun and the planets deep in our solar system. Now, get ready to see the solar system as you've never seen it before, and see images that were so good they shocked astronomers. Burning with the energy of 1 trillion nuclear bombs per second, the Sun is the largest body in our solar system, accounting for 99.86% of the total mass. One of the most dramatic images of the Sun was captured by the Solar Dynamics Observatory on August 31st, 2012, when a long filament of solar material that had been hovering in the Sun's atmosphere erupted into outer space. This beautiful but deadly coronal mass ejection, CME, traveled at over 900 miles per second. The planet closest to the Sun, orbiting at an average distance of 36 million miles, Mercury, has been studied by many spacecraft throughout the years. But NASA's Messenger spacecraft was the first to orbit the planet, Images showed the surface covered in craters in all sizes and massive asteroid impact sites like the Van Eyck crater, which is 168 miles in diameter, and the Calorus Basin, which is 960 miles in diameter, with mountains at the outer rim 1.2 miles high. These are images with spectral surface measurements that were taken on April the 29th, 2015. Messenger snapped more than 200,000 images of Mercury before ending its mission in 2015 with an intentional crash into the planet's surface. The probe's demise was inevitable, as Messenger had been orbiting Mercury since March 2011 and had run out of fuel. Right before impact, it sent back its final image, the highest resolution photo of Mercury ever captured. You'd think that Mercury would be the hottest planet because it's the closest to the Sun, but our next planet is actually the hottest in the solar system. The second planet from the Sun, and also Earth's closest neighboring planet, Venus, has a thick atmosphere made up mostly of carbon dioxide, sulfur dioxide, and nitrogen gas, which traps the heat of the Sun, making it a hellish world. Venera 13 was a probe built in the Soviet Union for the Venera program to explore Venus. It was the first lander to transmit color images from the surface of Venus. Venus is a hot world, with surface temperatures as high as 880 degrees Fahrenheit. The probe was designed to only last 30 minutes, but it must have been built like a tank, because it continued to transmit data and images for more than 2 hours after landing on March 1st, 1982. NASA then sent the Magellan spacecraft to Venus in 1990 to image and map the entire surface. It sent back images of the planet's surface showing evidence of volcanism, tectonic plate movement, turbulent surface winds, and miles of lava channels, including one measuring 5,550 miles long. Another incredible image of the volcano Mat Mons that rises 3 miles. Once Magellan was finished mapping the entire surface, it also ended its mission and crashed into the fiery planet. The third rock from the Sun, the Earth, is very unique and the only place known to have life in the solar system. There have been lots of amazing images taken of the planet we live on, but modern satellite photos are probably the most breathtaking. Like this image from NASA of the Earth as it looks right now. This amazing true color image was taken by NASA's Moderate Resolution Imaging Spectroradiometer from 22,000 miles above the Earth and shows North and South America as they appear from orbit. The Moon also making a guest appearance in the background. And on December the 14th, 2020, NASA captured a total solar eclipse with the GOES 16. That's quite amazing. But here is something you may not have seen. In March 2011, a Russian satellite named Electro-L captured incredibly detailed images of the Earth that appear to rival NASA images. Many claimed that they are more accurate and show different things, but NASA say they're not accurate. We're not sure. But which images do you think are the best? And by the way, remember the Messenger spacecraft? It snapped a photo of the Earth and of the Moon and sent us a postcard before speeding towards Mercury. Mars has always been of great interest to humans. The fourth planet from the Sun, the red Martian planet, has been studied heavily. The Viking Orbiter 1 took stunning snapshots of Mars in 1979, like this photo of the Valles Marineris. And the Viking 2 orbiter snapped an image showing the southern polar plains and polar ice cap. In 2013, the Mars European Space Agency's Mars Express took highly detailed images of Hebes Chasma, the northernmost part of Valles Marineris, as seen in this movie created from the images. But since then, 4 rovers have already been on the planet's surface, studying and snapping photos. The images from the Mars Curiosity rover, including a selfie, were the most incredible images from the surface of an alien world. This is a 1.8 billion panoramic view made up of over 1,200 images of Mars as seen by Curiosity, which is still operational. The largest planet in our solar system, the gas giant Jupiter, has the most unique look of all the planets with its giant Great Red Spot, a storm on the planet that's been raging for 350 years and is so large it could swallow the Earth whole. On July 10, 2017, the Juno spacecraft flew just 5,600 miles above the Great Red Spot and nabbed the closest image of the massive storm ever taken. This image, a bit farther away, is a little bit truer in color to what we would see if we were orbiting Jupiter. But Juno also captured unbelievable images of polar regions, which cannot be seen from Earth. And what surprised astronomers was that Jupiter's North Pole has 8 storms swirling at its center, and they're laid out in a precise geometric pattern, the storms appearing as stable fixtures in Jupiter's atmosphere and not normal weather. But more incredible photos would come, and on November the 13th, 2018, a new image from Juno was created using data from the JunoCam imager that's nothing short of breathtaking. And on June 27th, 2019, the Hubble telescope captured the planet's trademark Great Red Spot, which researchers say is shrinking. We got an awesome video coming up on Jupiter, so make sure not to miss it. As the #1 contender for the most beautiful celestial body in the solar system, Saturn is hard to beat with its iconic rings. And probably the best images of Saturn to date come from the Cassini-Huygens spacecraft. On October 21st, 2002, the spacecraft was 177 million miles away from Saturn when it snapped this photo. And on March the 27th, 2004, as it got closer, took this natural color image as it neared its arrival into Saturn's orbit. Now here's a mind-blowing image of Saturn you may never have seen before. This is Saturn backlit by the sun, and with that added light, Cassini was able to image the ring system in a way not possible from Earth, and the result is stunning. But in 2004, the Hubble telescope was also in on the action and snapped an amazing photo of an aura. In 2016, the Cassini spacecraft sent back images of Saturn's northern hemisphere. What scientists were surprised to see was a hexagonal vortex storms. They've been studied, but no one's sure how this forms. On September the 15th, 2017, the spacecraft made its final approach towards the gas giant, and before sending this final image, burned up in Saturn's atmosphere like a meteor. Known as the sideways planet because it rotates on its side, the 7th planet from the Sun. One of the best images taken, Voyager 2, made a flyby of the planet in 1999, and this image was taken using 3 color filters. And on July the 11th and 12th, 2004, a composite image of Uranus obtained by the Keck telescope was published showing the icy cold world and its rings. Those bright spots that you see on the surface of the planet are auras. In November of 2011, the Hubble telescope snapped an awesome image of Uranus, and a colorized photo shows an icy blue sphere with red rings. And in 2017, the Hubble telescope captured auras again on Uranus. Neptune is the 8th planet in our solar system, and the farthest away from the Sun. The only spacecraft that's been close to Neptune is Voyager 2. One image taken by the spacecraft shows a giant storm raging on the surface of the planet, Neptune's great dark spot. Before Voyager 2 would complete its mission and head towards interstellar space, it made a close approach and snapped this image showing bright cloud streaks in Neptune's atmosphere. The Hubble telescope has taken a recent image of Neptune and in December 2020 snapped this image with the Great Dark Spot. Because it's so far away from us, the best images we have of Neptune from Earth so far was taken by the European Southern Observatory's Very Large Telescope using a special narrow-field adaptive optics mode of the multi-unit spectroscopic explorer instrument. Many argue whether Pluto is a planet or not, but you're here to see some photos. One of the clearest images of Pluto that you'll ever see was taken by the Long Range Reconnaissance Imager, which is aboard NASA's New Horizons spacecraft on July the 13th, 2015. But it wasn't done yet, and on the next day, this image was put together by combining blue, red, and infrared images taken by the spacecraft. The New Horizons spacecraft continued to take crystal clear images of the planet. Pluto also has a moon called Charon, as seen in this composite of enhanced color images. And this image is the most striking, showing mountains across an icy plain. Humanity has achieved great results getting new images from planets in our solar system and making incredible discoveries. We're still too far away to get close images of Proxima Centauri, the next planetary system to ours, and current spacecraft headed in that direction will take thousands of years to get there. But there are plans to create a wafer-thin nanoprobe called Breakthrough Starshot that has thin sails to capture energy from a powerful Earth-based laser. This would accelerate the probe at 134 million miles per hour, meaning the tiny probes could reach Proxima Centauri in 20 to 25 years. Just think of the images it could take. If that happens sometime soon, you'll see it here.